Here are the answers to the Day 2 warm-up. Solve each problem. Show the math expression used and answer with appropriate label and the correct rounding. Question A, convert 200 miles per hour to a speed in meters per second. I'm going to write the given measurement down, 250 miles. And then when it said per hour, I'm going to write it on top of a fraction line and write 1 hour underneath. Then multiply by a conversion factor. First, let's change miles into meters. In the question, we're told that there are 1,609 meters in 1 mile. These labels will cross-cancel, leaving meters on top, hours on the bottom, meters per hour. The directions ask us to give an answer in meters per second. So let's multiply by another conversion factor and change the label in the denominator from hours into seconds. In the question, we're told that 1 hour has 3,600 seconds in it. These labels cross-cancel. The label that remains on top is meters, the label on the bottom is seconds, meters per second. On a calculator, multiply 250 times 1,609 and then divide by 3,600. The result on the calculator is 111.736. Let's think about rounding. The first number in the calculation, 250, has 2 significant figures. The second measurement has 4 significant figures, and the last measurement has an unlimited number of significant figures because by definition there are 3,600 seconds in 1 hour. The measurement with the least number of significant figures had 2, and so our final answer needs to have 2 significant figures. Let's round this to 110. The label is meters per second. Question B, calculate the amount of energy in 1 photon of ultraviolet radiation given its wavelength. The formula to find energy is E equals h times nu, where h is Planck's constant and nu is the frequency. This question doesn't give us the frequency. It gives us the wavelength lambda. So we actually need to use another formula that we learned. C equals lambda times nu. This second equation can be transformed so that the nu symbol is alone. Nu equals C divided by lambda. Make the substitution for C the speed of light, and the substitution for lambda the wavelength. And divide these two scientific notation numbers on the calculator. The result is 2.1414 times 10 to the 16th power hertz. I'm not going to round that answer off yet because I'm not done answering the question. When you're doing rounding, you want to retain as many decimal place digits as you can until you get to the very last answer, and then you decide how many digits to keep. Now that I know the value for the frequency, I can go back to the original formula that I had written down for energy. In place of h, let's substitute Planck's constant. 6.626 times 10 to the negative 34 power. In place of nu, let's substitute our frequency. And multiply these two scientific notation numbers together on the calculator. The result is 1.4189 times 10 to the negative 17 power. Now I'm going to do the rounding. All of my calculations involved multiplication or division, and so it's significant figures that matter. The original wavelength given to us had 2 significant figures, the 1.4, and so our final answer needs to have only 2 significant figures. 1.4 times 10 to the negative 17. Energy is measured in joules.